Hi everyone, we're the Pablitos. The Dark Night, Bringing Bats Back to Bristol by Pablitos in collaboration with the Bristol City Council. As sustainability has become a widely discussed topic around the world, countries have been making an effort to implement sustainable practices. And with this, data scientists, engineers, and others have come together to find easy to implement, environmental friendly, and effective solutions. The Bristol City Council has been leading the effort in creating black corridors in their city and urging others to do the same. That's where we come in. We have been invited to create an optimization algorithm that is generalizable to solve the problems of artificial light pollution and dehabitation. In 2016, 88% of European land surface was affected by artificial light pollution. In terms of bats, it has been observed that even after years of being around artificial lights, they haven't been able to acclimate themselves, continuing on with their daily activities. And now you may ask, well, why bats? Well, bats are pollinators, reforesters, and distributors of seeds, meaning that without them, many species, plant species, would not survive. Furthermore, bats are living in healthy and stable ecosystems, making them one of the most reliable natural indicators of environmental health. And they're very good in the economical perspective as well, as they eat enough pests to save up to $1 billion per year in pesticide costs. Our goal with this project is to decrease artificial light pollution and increase the number of black corridors for bats. And to do this, we have created an optimization algorithm to find the optimal grids in the city of Bristol, to turn off the lights during multiple hours of the night. So and then the environment's better for bats, but it's also safe for humans. The citizens of this city will still maintain the very important part of our project. And finally, we have created, Finally, we have created an interactive map and a website to inform citizens of the changes being made, their importance, and create a space for them to partake in this activity, ask questions, and give suggestions for how they hope and think that Bristol will reach a more sustainable and increased biodiversity state.
So what's our algorithm? Our algorithm is composed of a safety and a bat-friendly score, a fitness function, a generic algorithm, and an optimization of path. And with these 4 components, our algorithm provides us with the full light configuration for the whole city of Bristol so that both bats and the citizens can thrive in the city. And now you may ask, why is this the best algorithm? Well, following the guidelines provided by the Bristol City Council, we tried to make our algorithm and we made it generalizable so that it can be applied to other cities and even other countries. We also made it scalable, and it's really important because many factors have to be taken into account to assure the well-being of bats in the city. It is also super easy to implement. And finally, and most importantly, it takes into consideration the safety of the pedestrians and the drivers as well. So now let's move on to the website. So to include the citizens of Bristol in our initiative, we have created a website that contains a map. And in this website, the citizens can find out which areas will be turned off or turned on during different times of the day and even different times of the year. This way, they will avoid passing through these areas during these times. And we have also included in our website information about bats, a light override page, and a questions and recommendations form. In the Learn More page, we included information on bats, how they contribute to the community, and the role in the biodiversity of Bristol. And in the override page, the light page, the citizens can potentially turn on the lights of certain dark areas in case of an emergency or any sort of danger. And to do this, we have connected the website to the CMS, the centralized management system, so that the citizens can turn on the lights using their mobiles. We also have, of course, this will be strictly monitorized, so it's only used when it's strictly a dangerous situation. We also have a get in touch page in which the citizens can ask questions and even give us recommendations to enhance our light configuration in the city.
Now, we would like to briefly get you through the process of creating our algorithm. So first, we had to collect our data. And between the data sets provided to us by Bristol City Council and others, such as traffic accidents and crimes and trees in the city, we created our own data set. We used traffic accidents and crime to determine which grids, the safety of the grids, and the rest were used to determine how well suited for bats an area was. Then we had to do some data cleansing, so we changed northing, easting, latitude, and longitude to grid reference, which is a common map reference tool used in the UK. We substituted words in the data set such as few, present, and abundant for randomly generated numbers inside a range. We combined all of the data points by grid reference, and lastly, we found each one of the 8 neighbors of each one of the backgrids, as you can see here on the screen, and so that was our process. And so we did some data exploration. Of course, our most important variable was the bats and where they were located in the city. As you can see in the map, they are pretty much scattered around the whole city with a few concentrations. So our goal with the algorithm is to keep those areas where the bats are present dark whenever possible, and to select one of those clusters to create the dark corridor. Another important variable to consider is how the light affects different types of species, since some of the species are not very much influenced by light when the bats are moving around. In fact, as you can see in the pie chart, those are the majority of bats observed in Bristol. However, that can be because the other bats that are more impacted by light, their movements are being impaired by the lights and they're flying less because of that. So our focus will be those bats that are impaired by light when creating the dark corridors.
So now, this map So this map represents the final product of our winter algorithm. The red spots refer to the streets that will be kept turned off starting from 30 minutes after sunset until 4 a.m. And the spots that are represented in yellow refer to these street lights that will kept.
Wait. So actually, this is the map for the street lights in Bristol, which will also take into consideration to know which places in the city need to have more lights and which have no lights, because some places did not have lights. So now, finally, we are building our algorithm. So we divided it into winter and summer, because in winter, bats are hibernating. So for winter, we created bat-friendly score and safety scores, and then we combined them together into a fitness function. We optimized that function to find out a good balance between those two scores and to provide us with the optimal light configurations for the grids. But because we are only concerned on the places that the bats are present, we only ran the function through bat grids and the neighbors, because light coming from those neighbors will also affect the bats. But that gave us a problem because some of the bat grids were close to each other, we had some neighboring grids having more than one light configuration assigned to them. So we created a genetic algorithm which considered all of the grids in Bristol at once, and then once again provided us with the optimal light configuration. And that was our final solution for winter. As for summer, we had to create the dark corridor so that the bats can fly around. And so we first selected only the grids that had more than 100 bats that are affected by light, and the grids that have more than 100 moths. We then selected the 3 closest moth grids to each one of the bat grids, and we found the distance between them, creating a straight line between them. Then we saw all of the grids that straight line went through, and we used their safety score to determine which places would be the best to turn off the lights, taking into consideration how long that path was and the safety score. And that, in the end, was our final result for winter.
So now this is the real map that represents our solution to the winter algorithm. And as I previously explained, the red spots represent the streets that will be turned off starting from 30 minutes after sunset until 4 a.m. And the yellow ones are the refer to the street lights that will kept on. And the same goes for the summer algorithm. Now let's talk about how the Bristol City Council is going to implement our solution. So to answer this, we came up with some recommendations that we give to the Bristol City Council so that they assure the success of this project. So first of all, we would recommend the Bristol City Council to create a policy for gradually adding more dark corridors as the number of bats and habitats increase. We also would recommend the Bristol City Council to create a policy for the valid emergencies and dangers for turning on the lights. And we would also recommend them to add flyers on the streets that will be turned off so that the citizens will be aware of the reason why these streets are turned off and can even get in touch with us on the website that we created. And finally, in the future, we would recommend the Bristol City Council to collaborate with Google Roads so that the citizens can know which roads will be turned off and then they can go through other alternatives.
So we would just like to say that with our algorithm, you will find a more sustainable future with decrease in artificial light pollution, increase in bat populations and habitats, decrease in spending, better sleep and internal clocks for humans and bats, and reduces carbon emissions. Thank you.
Thank you very much, and maybe now time for some questions.
Okay, so very nice presentation and very nice work. I really like the idea of taking into account and stressing the importance of public awareness and involving the citizens in the system. Both with an information channel and a feedback channel. I think that's a very, very important aspect in all these types of problems. I don't have a lot of technical questions because I think it was clear. It was also, I like the idea of using genetic algorithms and the way you framed the problem. One thing I did not fully understand was in the division between summer and winter. So you said that it's known that the bats hibernate during winter, but when they're hibernating, they're still light sensitive?
So that's the thing. In winter, they move around less because they do hibernate. So the lights will still be turned off in specific areas, but because they're not going to be moving a lot, we didn't take into consideration the distances and create those paths for them. Okay. And in summer, because they're moving around, looking for food, mating, all of these things, we have created paths for them. And in both winter and summer, as Hiba mentioned, the lights will be turned off from 30 minutes after sunset to 4 in the morning to adjust for early risers that have to go to work.
Okay.
And to add to what Joana just said, so when we did the research, we found out that even though they hibernate, they still need the lights to be turned off. So we made sure that in the locations where the bats are going to hibernate, it's going to be turned off. And from these locations, we built the path that they're going to take to find the moth for winter. So both the winter algorithm and the summer algorithm are connected. So it's the most efficient way for us to handle this situation.
Okay. Just out of curiosity, so in running the genetic algorithm, so how many cells does the map have? How many variables?
You're saying the Bristol grid reference?
Yeah.
The number of iterations?
No. The number of variables that you need to optimize with respect to.
The algorithm, in this case, because we only took into account the one that had the neighbors and the bad grids, they were about 1,574. And each of them had 2 possible configurations, but we reduced the problem before that, as first we focused on the bad grids and its neighbors, so we optimized for those 9, and then the genetic algorithm was just passed through those that still were undecided, because sometimes the bad grids were neighbors of themselves. So after doing this, it reduced the problem to about 120 different grids that we didn't know yet. But doing that before passing it to the genetic algorithm already like created a big increase in the performance of the fitness function. So
And how
that
long
did
does it
most of
take?
the job.
How long does it take?
That's one of the kind of the problems that we faced, that it did take a long time to run. So we did put we built the framework, but it would need like a bit of a powerful computer to run it many times, because it did take some times. In our case, we ran it not that many times because we were finishing it one day before the entry, so we just did 60 as the population size and 60 generations, but this could be easily increased if you desired. And if you even run it like in a good computer for maybe a day or something, it would obtain really good results. So.
Okay, thank you.
Thank you so much for your presentation. I like a lot of things that I saw, and again, the interaction with the citizens. So I have two questions as usual, but one at a time. So the first one, I saw in your notebook that other cities, they were doing that, okay, the interactions with the citizens. So just a curiosity, did you see the benefits, and did you see if the persons were misusing that ability to turn on and turn off the light?
So in the examples that we saw, the cities were doing that for different purposes. So they were doing to save energy. It was not regarding bats. And so they left the example that we saw in Germany, where they did what we proposed, that is so that citizens can turn on the lights if they need to. It was to save energy. And so we didn't look too much in depth like how they performed, because we already had an idea on how it would work in our case. But that's what we thought too, like we need to have certain control over it to know like if people are not misusing it. So that is why after someone asks for a light to be turned on, we will send them like a form for them to explain to us like what happened, why they felt that the lights had to be turned on. And we also ask them like to register so that they can do that, so that we can keep a certain control.
Okay.
And at the end, that's why we also recommended the policy of giving examples of what danger or a serious situation could be to turn off the lights.
Okay, awesome. One question that I had been asking is that, okay, so imagine that you're selling this to someone, okay? What will be the activities that you envision that needs to be done, and what will be the effort, whether this is computation, whatever, that you need to deploy a product?
So what we need for this to be viable is the CMS, the Central Management System, so that we can put our algorithm in a computer that will say to the CMS, okay, turn off these lights, and these can be kept on. So basically, that's what you need, and then there are other measures that what we advise that can be made so that citizens can be aware of it. So what we said about putting flyers, like for example, this street will be kept dark, so let's put a flyer here with a QR code for the website so that people are aware of that and not go into a street that is dark without knowing it. So basically, that's what we thought of.
And also to add to what Beatriz said, the solution is also very cost effective for the Bristol City Council. So we made a website, of course, so it will handle the part of the raising awareness with the citizens, but also to implement our model, as we already mentioned, it's very easy to implement. And the only main, I would say, investment in this product would be the computer that has to be super powerful, not really powerful, but a bit powerful to run the model in one day.
And another thing, which I think the other groups also mentioned, is the data collection part, because we have information from like a long time ago, so it's not really possible to say, okay, here's where the bats are right now. We would have to, so the investment would be in the data collection, basically, because that way, if you start collecting data every certain time, you can also even start making maybe predictive models so that you know what the configuration of the lights will be for the next week or the next day, and so on. Because this is like static. It's one solution for hibernation, or a solution for the feeding period. But if you really collected the data, I think that with the model that we made, you could really put something that could actually cause a really good impact.
Thank you so much. Thank you so much for your presentation again.
Thanks for your presentation. Really congratulations for including people and citizens in your solution. It was already said, but I think if we say it, it's because it's super important. This is not very often done when we are talking about smart city. Very often we have top-down solution. So what you are doing and trying to do is really important. And so I was just wondering, like, at the end, who has, so when, if you answered a bit the question, but not totally, like, at the end, will it be automatic? Like, if, for example, a citizen want to turn off a light, a street light, so he has to answer the Google form, and then, like, what happened after? Like,
yeah, so I mean, the goal was if there is a dangerous situation or an emergency of any kind, so there's fire trucks coming, there's a fire, someone, whatever, any of those things, the people need to have the ability to turn on those lights if they need to, because we don't want to leave them in a horrible situation that they can't help themselves with light to get away or to take someone somewhere safe. And that's why we're going to have the form later. And I mean, going into the policy, maybe there can be something implemented beyond what is dangerous or an emergency to say if you don't respond within this number of time, you know, either you can be a part in the system where it won't let you turn on lights again for a certain amount of time, but then we want to keep the safety of the citizens. So most likely it might be just a little fee if you didn't say, because we don't want people to abuse this power.
So.
Sorry, it's because, so I think you're asking how we would, how someone would say, I want this light to be turned on. So we put in the website like an option where you can use your location, and then the system, it would identify where you are and turn on that light.
Okay, but so in the loop, do you still have a human in the loop, like an expert that will accept or not the recommendation from the citizen?
Recommendation from the citizen.
Yeah.
So yeah, we have a page where you can make a recommendation, and that would be something that we haven't made something that would make it automatic. It would be something that someone would have to go over it, see if it adds up, if it makes sense, and then that could be put into the algorithm in a number of ways.
No, I was just going to mention, just because, I mean, the point of this project is to create dark corridors and to create a better environment for both humans and bats. We need to keep in consideration that we have to push this effort. If we want to become more sustainable, we have to take steps to become more sustainable. So if, like, people take advantage of it or say, oh yeah, we're going to turn on the light whenever we want or anything like that, it's not going to work. So, I mean, we have to make sure that there are some sort of boundaries so we can protect the animals as well.
And what is really cool also about your project is that you are bringing awareness about urban biodiversity. And do you have other idea to, I don't know, like create maybe an app, create a user-friendly interface around streetlights, you know, I don't know, to make it more decentralized and more... Yeah.
So we had this idea of creating an app, but the problem with an app is that, I mean, not many people will download it at the beginning, because usually people, when they know they won't use an app, they won't install it. So we prefer to go at the beginning with a website, and if we see that we're receiving a good feedback and that it's working, then we will consider creating an app so it's easier for the user. But also, to fill up the form, it's super quick. It's just a website. You can scan here and find out the website, our website. So it's super easy. You just have to click, fill in the form, and I think it's really, really user friendly. So we didn't really consider creating an app.
Yeah, and in the questions, to be quick, as Hiba mentioned, it's just first name and last name, email, and place. Just so because if it's in a case of emergency, you want to be quick. And those things we feel are the fastest things to put in. And that's why we're sending the form later and not at the moment. They have to fill why they're turning it off.
Thank you.
Thank you. Thank you very much for your presentation. Again, I don't have any questions, but I think, yeah, I just really appreciate the inclusion of the communications with the general public and the policy, and even the web form. They're all things that we recognise that we have to do a lot of in local authority, so that's all really relevant. So thank you for including those.
Thank you.
Thank you.
All right, and then I have one question from Gitty, of course. First, a compliment on the awareness campaign and the flexibility of the map. Smart that there is a division between summer and winter as well. And great understanding of bats. So congratulations on that. And question, could you also collaborate with Google Routes to scan for bat routes if there is more data available in the future? Some citizen might also like these routes after your awareness campaign.
So, go ahead.
Okay. Oh yeah, definitely. So our idea with Google Routes is that we know that many people in Bristol use Google Routes on a daily basis, and so what we thought we can do, as I mentioned before, is that you enter a location, you enter an address that you want to go to, and the GPS will take into account the lights the streets that will be turned off, so that it can avoid passing through it, and also give alternatives. So give the alternative to streets that will turn on. And of course, as Marcelo mentioned before, data points are super important. They make all the difference. So of course, if we have more data points, that will increase the accuracy of the roads, and even give if we can make Google Roads give us faster and more efficient alternatives, that would be great.
Okay, thank you very much. Is there any last question? We have 1 minute. No? Everything's clear? Thank you very much.